Alright, so we're going to do another problem here. This time we're going to look at the electric field. So we'll start by imagining we have some charge. Okay? And it has a net charge of minus 300 microcoulombs. Or minus 300 times 10 to the negative 6 coulombs. Now, we're going to have an electric field that the charge is present in. Now, the electric field has a magnitude of 80,000 newtons per meter. Sorry, newtons per coulomb. Okay? What I want to know is the magnitude of the electric force that this red charge feels. So, the only force, if we were to draw a free body diagram, is the force exerted by the E field. Because it weighs so little, we're not really interested in gravity. So, and I don't necessarily know the direction, this is just an example, the E field's pointing to the right. But we're looking for the magnitude, so it's not too important. Okay, so the force exerted by the E field onto the charge is the absolute value of the charge times your E field. So the absolute value of our charge is minus 300 times 10 to the negative 6 coulombs times 80,000 newtons per coulomb. So I'm just going to make this positive real quick. If we look at our units, we can see the coulombs drop and we're left with just newtons, which is what we want. And if you were to plug this in, you should get about 24 newtons. Okay? So, real quick, you might have seen this equation before, which is that the electric field itself is equal to K, the magnitude of the charge, divided by R squared. Now, the reason why this wasn't important is because this is for the electric field created by a point charge Q. We're not actually interested in what's creating this electric field. We're interested on how a point charge, the force a point charge feels inside that electric field. So this isn't necessary. I just wanted to point that out because I've seen that as a question before. So hopefully that